We're asked to find the derivative of each function. Let's begin with f of x. We are given f of x equals tangent of sine of negative 3x. Notice here we have a composition of functions. We actually have a composition of 3 functions, but because the outer function is the tangent function, we will be using the derivative formula. The derivative of tangent u with respect to x is equal to secant squared u times u prime. So u, the inner function, is going to be sine of negative 3x. Also notice u is also a composite function. So if we let u equal the sine of negative 3x, we'll also need to find u prime, or du dx, and let's find that now. U prime is equal to the derivative of sine of negative 3x, and again we have to apply the chain rule, where the derivative of sine u with respect to x is equal to cosine u times u prime. Notice in our case now the inner function is negative 3x. The derivative of sine negative 3x with respect to x is equal to cosine of negative 3x times the derivative of negative 3x, which is negative 3. U prime is equal to negative 3 cosine negative 3x. So again, we're given f of x equals tangent of sine of negative 3x, but because we let u equal sine negative 3x, we can think of the function as just tangent u, and the derivative of tangent u with respect to x is equal to secant squared u times u prime, which indicates f prime of x is equal to secant squared u is secant squared of sine negative 3x, and then times u prime, where u prime is negative 3 cosine negative 3x. So this is the derivative function. Let's go ahead and write this as f prime of x equals negative 3 secant squared of sine of negative 3x times cosine of negative 3x. I just moved the coefficient of negative 3 to the front. And that's what we're going to determining the derivative of g of x equals cosine of cotangent 2x. Notice in this case the inner function is going to be cotangent of 2x, so we'll let u equal cotangent 2x. To find g prime of x, we'll be using the derivative formula. The derivative of cosine u with respect to x is equal to negative sine u times u prime. Our next step is to determine u prime, or du dx, which is the derivative of cotangent 2x with respect to x. Looking at our formulas, the derivative of cotangent u with respect to x is equal to negative cosecant squared u times u prime, where in our case the inner function is 2x. The derivative of cotangent 2x with respect to x is equal to negative cosecant squared 2x times the derivative of 2x, which is 2. Simplifying, we have negative 2 cosecant squared 2x. So again, we are given g of x equals cosine of cotangent of 2x. But again, because we let cotangent 2x equal u, we could think of g of x as just cosine u. And the derivative of cosine u with respect to x is negative sine u times u prime, and therefore g prime of x is equal to negative sine u is negative sine of cotangent 2x, and then times u prime, where u prime is negative 2 cosecant squared 2x. Let's also rewrite this. Notice how we have a negative times a negative. Let's write g prime as g prime of x equals positive 2 sine of cotangent 2x times cosecant squared of 2x. I hope you found this helpful.